How's it going, everybody? So today what we're going to be talking about is the characteristics of quadratic functions. Now there's going to be quite a few things that we're going to need to learn about quadratics. Now there's going to be a lot of similarities though that we can take from the absolute value. One of them is definitely being the first part of these notes where we find the vertex, the axis of symmetry, the domain, and then also how we articulate the range. Now the only difference is the idea of maximum minimum. Now, the idea of maximum minimum has been, I think, expressed to you in Algebra 1 or even here in Algebra 2, where the idea is that the maximum is relating to the idea that it is the highest point on the graph, and then the minimum is articulating that it is the lowest point on the graph. So let's go ahead, take a look at number 1 in depth and see what we mean. So when looking at for the vertex, we're going to go ahead and pinpoint the lowest point on the graph, or the highest point. And if you look at it, it's this right here. That would be the lowest or highest point. And since that is actually the lowest, we would call that a minimum, okay? Because he's the minimum value of this quadratic function. Now the vertex, of course, is this right here, okay? This is the vertex. Now the vertex is going to be 2, -4. Now, the axis of symmetry, of course, is derived just like when we did the absolute value function. It's the x value of your vertex. So, of course, that is going to be x is equal to 2. And, of course, that symmetry is seen if you cut it right down the middle. It splits our quadratic in half. Now, the domain for any quadratic function is always going to be from -infinity to +infinity because it's not restricted going left to right. Now, it is restricted in terms of the range because we read that from bottom to top. And the furthest it can go down is going to be to -4, okay? Now, of course, that is indeed a bracket because it's a closed circle. Now, it's not restricted going up, though. It gets to go towards +infinity. And so that right there is just a couple of the characteristics from number 1. Now, let's do the same thing for number 2. So for number 2, the vertex, okay, we'll go ahead and pinpoint where the lowest or highest point is. And it looks like it has a high point right here. And so instead of it being a minimum, this is now the tallest point on the graph, or the highest point, so it's the maximum. Now that same point is indeed the vertex, and so we have ourselves a -2, 1. And then the axis of symmetry is the x value of your vertex. Now the domain is not restricted at all. It goes from -infinity to +infinity at all times. But the range is. There's a certain point in time where as you look from bottom to top, it hits a peak, right? It can't go above 1. So it goes from -infinity all the way up to +1. And of course at 1 you can include it because it's a colored in circle or a solid line, okay? So that right there is 1 and 2. Now, going more on this idea of the axis of symmetry, we've talked briefly about it, that it's the idea that it cuts the graph in half. It's the idea that it's the x value of your vertex. But what's unique about the axis of symmetry is that it can actually help you plot points. Like if you know a partial piece of the graph, you'll notice that the points are always equidistant on either side. So for instance, looking at this first one, number 3, if you look at it, you'll notice from here to here is just one space. So if I do that to the right-hand side and just go over 1, this is my point on the other side. And then, of course, for the second point that's down here, if I go over to the axis of symmetry, that's 1, 2. If I go 2 to the right, 1, 2, I have perfect symmetry, okay? And I have the other part of my graph. And that's the whole point of the axis of symmetry, is that it is supposed to be mimicked on the other side. Same thing for number 4. Look at the distance from the axis of symmetry. So it's just 1. So you just go 1. Then look at the next point. It's 1, 2. So from here, you go 1, 2. And then you have yourself the other half of the quadratic function, okay? So this right there tells us a little bit more about what the axis of symmetry's importance is and why it's there, okay? Also, a little tiny blurb that you may want to write is that the distance from axis of symmetry is equal for each point. And we just did that, right? Because we understood that they were equidistant from the axis of symmetry, we could create the other side of the graph, okay? So that's the idea between 3 and 4, and kind of elaborating more on the importance of the axis of symmetry. Now, number 5, okay, this is going to articulate the idea of increasing and decreasing. Now, this will be more helpful probably when you get closer to pre-calculus, but getting exposed to it now will definitely help and prepare you for those moments, because we study increasing and decreasing at these vertexes, okay? So once again, find the vertex of this graph. Well, the vertex right here is going to be -2, 1. And the idea of how we interpret it is always we read increasing and decreasing like we read domain or like we read a book. We read it from left to right, okay? So read it from left to right, okay? So looking at this graph right here, if I were to trace along the graph, I'm going from left to right. I'm going up here, okay? Because if you kind of just trace along the graph, you're going up, 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 just like that, okay? And so you're going up. And I'm sorry, it may have not shown there when I was saying that, but the idea is that as you read it from left to right, you're going up. But the minute you hit that vertex right there, you'll notice you'll start to go down, okay? And it's very evident because your arrow is pointing down, right? So the way we describe it is actually in terms of domain. Just because we read it from left to right, we also describe it like domain. So we have it from -infinity, okay, to -2 because it's increasing there. Now the idea is that when talking about increasing and decreasing, you're going to go ahead and say a parentheses, even though there's a colored in circle, because the idea is that when you finally get all the way to this dot, the idea is that you would then be kind of pointed like this. This is how your arrow would look when it hits the top of the vertex, okay? And with that being said, you're not increasing or decreasing at that specific point in time. So this right here cannot be included in increasing, and it can't be included in decreasing. But the minute this arrow starts to tilt, you'll notice he starts to go down, okay, like the arrow, the red arrow is showing. So here, we would say from -2 to +infinity, I am decreasing, okay? Now with number 5, if it was a little iffy on whether or not you understood it, let's look at number 6, okay? Let's see if this might help. So once again, taking a look at this, find your vertex. Vertex is right here at 2, 1. Now read it from left to right. So left, you'll notice that as we trace along, we're going down at this point in time. But the minute we hit the vertex, we spin back around and we start going up. So in terms of increasing, I'm increasing from 2 to +infinity, okay? So the idea is from this point right here onward, I'm increasing. Now, from this point over here -infinity to here, I'm decreasing. So I would say from -infinity to 2, I'm decreasing. And of course, you can't include 2 because when you're at that vertex, you're not going to be having a positive or negative slope, right? You're just at 0. Alrighty. Now, let's take a look at this next part. Okay, so this right here is a good representation of some characteristics that you could see in your textbook. You'll notice the biggest way that they describe quadratics is in the form ax squared plus bx plus c, okay? That form is going to be something I'm going to be drawing on a lot because it's going to be used a lot when helping us solve for our vertex and also the axis of symmetry, okay? This thing right here. So it's important that we know what the b value is. It's important that we know what the a, c value are. All those things are important. And then it also helps us when we go to find the y-intercept, okay? Because this right here, if you know that the y-intercept is your c value, you really don't have to necessarily do any mathematics. You can just instantly pinpoint where it's located, and then boom, you've got yourself a y-intercept. So go ahead, take advantage, and definitely memorize this right here. You're going to want to memorize this, and it's not hard to memorize because it just goes ABC, okay, just like ABC. So not too bad to understand. Now, there are some other big points on this little table here. It says the parabola opens up when a is greater than 0 and opens down when a is less than 0. So the idea behind that is this is communicating when the a value is like a 1 or a 2 or a 3. But if your a value is less than 0, that's things like -1, -2, -3, okay? So that's why this opens down, because it has a negative a value. This over here opens up because it has a positive a value, okay? And so that's what the first bullet point is describing. Now, it goes on to say that the graph is narrower when the graph of f of x squared, when the a value is going to be greater than 1, and then it's wider when the a value is less than 1. Now, that will be articulated more when we talk about transformations and those ideas, but we'll wait till we discuss transformations in more detail, okay, with quadratics. Now, let's kind of use what we highlighted. And another big thing I guess I should have highlighted is we're going to definitely use this top one right here, okay? So these three that I highlighted, make sure you pause this and write these down, because we're going to be using these a lot. That second bullet point we'll come back to in the future, okay? So let's take a look at number 7, okay? What we're going to be using, okay, to find the vertex and the y-intercept are those 3 bullet points. Now, it said that the equation for the axis of symmetry, okay, that is going to be x is equal to -b over 2a. Now, this right here, like I said, it's important to be able to label what a is and what b is and what c is. Well, in this number 7, a is going to be 1, b is going to be -4, c is going to be 6, okay? And so looking at this right here, you just need to plug these values into your axis of symmetry. So this right here ends up being x is equal to a -4, because it's a b value, divided by 2 times a, and a is 1. So this ends up being 4 divided by 2, and 4 divided by 2 is 2. So your axis of symmetry calculated is going to be x is equal to 2. Now, that's not your vertex. The axis of symmetry is the x value of your vertex, and so we're missing the y. And so in order to do that, we have to take our axis of symmetry and plug it into the original equation. And the original equation I'm talking about is this guy, okay, what I highlighted in blue. So let's go ahead and do that. So I have my f of 2. Now remember, when you say f of 2, that means wherever there is an x value, you're going to plug in 2. So that means I have 2 squared minus 4 times 2. Sorry about moving that, guys. Plus 6. And so that gives me my y value, because f is a fancy way of saying y. That gives me 2 squared is 4 minus 8 plus 6. And so y officially is going to be, it looks like a 2. So your vertex is going to be 2, 2. So let's go ahead and write that. Vertex is 2, 2. Now, the idea behind our y-intercept is it's the c value, right? Well, if we already know our c value, and it's this, then we know that the y-intercept is just going to be 0, 6, okay? So all you got to do is identify that. Now, you can also easily see the c value just right there. So the y-intercept is easy to find. Now, mathematically speaking, the reason why we can do that is because the y-intercept is found when all our x values are 0. So the idea behind this is when f of 0 does this, if you just do 0 squared, that's 0, and -4 times 0 is 0. And so truthfully, all you're left with is 6. And so then that means 0, 6 is the y-intercept, okay? So that's how you mathematically get there. Now let's do the exact same thing for number 8, okay? So looking at this right here, once again, we need to find our axis of symmetry, and let's identify our A, B, C. So A is -3, B is 12, and C is 6. We'll come back to the C, that's our y-intercept. But the axis of symmetry is found with our -b over 2a. And so that means I have a -12, right? and then a 2 times negative 3. So that gives me negative 12 over negative 6, which in turn simplifies into 2. So once again, our axis of symmetry is x equals 2. Now we're going to plug in our axis of symmetry into our original equation to find our y value. So I have my f of 2. Once again, now it's not always 2, it's just coincidental, okay? Keep that in mind. So I have negative 3, and then I have 2 squared plus 12 times 2, and then plus 6. And so that means my y value is going to end up being, that's going to be 4, right? So 4 times negative 3 is negative 12. 12 times 2, that's 24, and then plus 6. So what this all adds up to be is y is going to equal 18. So that means my vertex is going to be 2, 18. So the idea is that first you need to go ahead, find yourself the axis of symmetry. And then step 2, plug it into the original equation, okay? So the idea is 1, find AOS. Then step 2, plug into original equation. So those are really the only 2 steps, okay? Now, of course, this also wants us to figure out, the y-intercept. Well, the y-intercept is just the c value, right? So that means my y-intercept is going to be, once again, 0, 6. Now, this is also coincidental. Please do not think that all y-intercepts are just going to be 0, 6. It's just based upon whatever that is, okay? Now, let's go ahead and take a look at the next part. Alrighty, so this next part is talking about the quadratic, but in this form called intercept form. Now, intercept form is really helpful because it helps us find our x-intercepts, okay? So to elaborate on kind of the process of what we just went through is this first one up here that you looked at, okay? This is called standard form, okay? This is the standard form for quadratic. What is circled in green, that is the standard form. This right here is called intercept form, and I'll go ahead and circle that one as well. This guy right here. This is called intercept form for a quadratic. And so, like I said, it helps us find our x-intercepts, and you can still find your axis of symmetry even with this format, okay? Now, the equation does change, though. You're not going to use x equals negative b over 2a, because you'll notice in the intercept form, you don't have the b and the c values. So you're going to need to use a modified one. You're going to use this right here, okay? The p plus q divided by 2, okay? So let's go ahead and take a look at how we use this. So looking at this right here, your p and your q are the negative 4 and the 6. So the 4 is my p and the 6 is my q. Now, when we go to find our x-intercepts, okay, we find it like this. We put our, what's in parentheses, equal to 0, okay? And then you solve. And so you add 4 to the other side, so x equals 4. And then you subtract 6 to the other side, so x equals negative 6. And so these right here are your x-intercepts. Easy peasy, right? Now, the idea is that when you have your x-intercepts, you can plug them into the axis of symmetry equation, the x equals p plus q divided by 2, to find your axis of symmetry. So you have your p value, which is 4, so you have 4, plus your negative 6 divided by 2. So this right here gives me a negative 2 over 2, and that simplifies down to negative 1. So your axis of symmetry is x equals negative 1. Now this is not the vertex. Remember, you got to take your your axis of symmetry, and plug it into the original equation to find the y value, to then have your vertex. So here, what you end up with is a f of negative 1 is equal to negative 1 minus 4, and then negative 1 plus 6, okay? And so f of negative 1 is going to equal our negative 5, and then, of course, a positive 5. So your y value is going to equal negative 25. So the vertex in the end is going to be -1, -25, okay? So there you go. There's our answers. Okay, we have our vertex and our x-intercepts. Now we're going to do the exact same thing with number 10. So once again, in order to go ahead and start finding the vertex, let's find our x-intercepts. Our x-intercepts are found by putting what's in parentheses equal to 0, okay? Don't worry about the -2. The -2 will not affect your x-intercepts, okay? And you do not want to distribute, okay? Leave him be. So then you're going to go ahead and solve. So x will equal 5. And then x will equal 1, okay? These are your x-intercepts. Now also, please keep in mind, okay? I know I keep saying that these are your x-intercepts, but remember how you write an x-intercept. An x-intercept is written like this: 5, 0, and 1, 0. Keep that in mind, okay? Because you can write them like this as well, okay? And that's the proper ordered pair, okay? Now, remember, we're going to use these values to find the axis of symmetry. And so I've got myself x is equal to my p plus q divided by 2. Remember, this is my p value, this is q. And so I've got myself 5 plus 1 divided by 2. That's 6 divided by 2, which is then in turn 3. So your axis of symmetry is going to be x is equal to 3, okay? Now, plug this into the original equation, okay? And so you're going to have your f of 3 is equal to -2 times 3 minus 5, and then 3 minus 1. So this in turn is going to give me a -2 times -2, and believe it or not, a 2. So when you multiply this all out, that's going to give me a 4, 8, right? So y is equal to 8. So the vertex is going to be 3, 8. All right, so there you go. Now, looking at this next part, okay? 11, very basic. All it's asking you to do is now look at a thing called vertex form. So let's kind of hash all this out, because I know I've thrown out a lot of forms, and maybe let's kind of bring it down to a nice, easy little bullet. So this right here is standard form, okay? Standard form is when you have your ax squared plus bx plus c, okay? Then you have your intercept form, which really helps you find your x-intercepts. So intercept form, okay? That's your a, and you have your x minus p, and then, or x plus p, however you want to look at it, x minus q, okay? And then you have yourself a vertex form, okay, which is what we're about to look now, so vertex form. And this is going to be our ax minus h squared plus our k value, alrighty? And so these forms are all quadratics. Keep this in mind. These all represent quadratics, okay? They're not like different types of functions. They're just different ways of writing a quadratic, okay? So just keep that in mind when we're looking at these problems. Now, I guess pause it real quick and then write those down. But looking at here, you can see a nice and more pretty version of what I just wrote for the vertex form. It kind of color codes it with the A, the H, and the K. And the reason for that is because those are important. Because the A value tells us our vertical shrink and stretches for our transformations. And then also, if that A value ends up being positive, then it opens upward. So that's important to write. If the A value is positive, okay, greater than 0, it's going to open upward. If the graph is, or the A value is negative, something less than 0, then it's going to open down, okay? So the H now, moving on to that indicates, of course, shifting, right, from left to right. And then the K is talking about up and down. Now, when you put the H and the K together, the blue and the green together, that actually creates the vertex. And you'll notice that's highlighted in the text right here. The vertex is H, K. And so the reason we call this the vertex form is because it literally demonstrates what your vertex is. And so you can kind of see how mathematicians aren't really original by how they name things. The vertex form really highlights the vertex. The intercept form really highlights the intercepts. And then, of course, standard form, unfortunately, just, I guess, highlights the standard form. It doesn't really highlight too much of any of the characteristics. But looking at these problems now, if you're looking at number 11 right here, you'll notice the 2 is positive, so that indicates to us that it's going to open up. And what I mean by opening up is if you were looking at a graph, it would do something like this. It's going to go up like that, okay? Now, it won't open up at the origin like that, but you get the idea. Now, the vertex is created from the h value and the k value. Now, this is your h value. This is your k value. Now, remember, the x's lie to you, right, when they're on the inside. And so I know that says -3, but think it in terms of the opposite. It's actually a +3. And then your 5 is fine. It doesn't lie. And so that is going to be your vertex. So this is the answer for number 11. Now, number 12, looking at this right here, you'll notice your a value is negative, okay? You see right here he's negative, so that's going to open down. It doesn't matter the number. It just matters this, is this number less than 0 or greater than 0? So I guess you could argue that it matters, but it's mainly looking at, is it greater than 0 or less than 0? So since it does that, looking at that on a graph, it'll do something like this right here, okay? And so this vertex is also thought in terms of the opposite because you have your h, you got your k. Now I know this says +5, but what's the opposite of +5 is -5. And then of course you have your -2, and then boom, there is your vertex, okay? Now we'll be using a lot of Desmos as well to verify our answers and to really, instill these characteristics of quadratics. And so guys, this is just kind of a rundown of what we will be experiencing over the next couple of days. And so don't worry, we'll get a really good opportunity to practice this, but this gives you a nice, good introduction of where we are heading. So great job, guys. And we'll talk about this later on this week. Thank you, guys. All right, bye.